Wind energy is important. It harnesses the natural power of the wind to generate electricity, providing a clean and sustainable energy source. It is a key part of renewable energy. By using wind power, we can reduce our reliance on fossil fuels and decrease greenhouse gas emissions. Wind turbines help us use this energy. These towering structures capture the kinetic energy of the wind and convert it into electrical power. They transform wind into electricity. This electricity can then be used to power homes, businesses, and even entire communities. Installing these turbines is a complex process. It involves transporting large components, assembling them on site, and ensuring they are securely anchored. It requires careful planning and many steps. Engineers and construction teams must work together to ensure everything is done correctly and safely. This guide will explain the process. We will break down each phase of the installation, from initial planning to final testing. We will look at each step. You will see how these massive structures are erected and brought to life. From site selection to final checks, we will see how it all comes together. Join us as we explore the fascinating world of wind energy. The first step is choosing the right location. A Geographical Information System, or GIS team, helps with this. They use data to find the best places. These places need strong and consistent winds. Once a site is chosen, preparation begins. This involves excavating the area. A large hole about 4 meters deep and 30 meters across is dug. This will hold the foundation. The foundation supports the tower. It is crucial for the stability and longevity of the wind turbine. The foundation is typically made of reinforced concrete, designed to withstand the immense forces exerted by the wind and the weight of the tower. The tower is made of steel sections. These sections are cylindrical and are designed to be both strong and flexible, allowing the tower to withstand high winds and other environmental stresses. These sections are very heavy. Each section can weigh several tons, making the assembly process a significant engineering challenge. A crane lifts and places each section. The precision required in this process is immense, as each section must be perfectly aligned to ensure the stability of the tower. The bottom section is the heaviest, weighing 60 tons. This section provides the necessary support for the entire structure, anchoring it firmly to the foundation. The sections are bolted together. This process involves high-strength bolts and precise engineering to ensure that the tower can withstand the forces it will encounter. On top of the tower goes the nacelle. The nacelle is a critical component, housing the machinery that converts wind energy into electrical power. The nacelle houses important equipment. This includes the gearbox and generator. These components are essential for the efficient operation of the wind turbine, converting the kinetic energy of the wind into usable electricity. A very large crane capable of lifting 750 tons is needed to install the nacelle. This crane must be carefully operated to ensure the nacelle is placed accurately and safely on top of the tower. Next comes the blades. These are the most crucial parts of the wind turbine, as they are responsible for capturing the wind's energy and converting it into mechanical power. The blades capture the wind. They are designed to be aerodynamic, allowing them to spin efficiently even in low wind conditions. This spinning motion is what drives the turbine's rotor. They are attached to a hub. The hub is a central component that holds the blades together and ensures they rotate in unison. This assembly process requires precision and expertise. The hub is connected to the rotor shaft inside the nacelle. The rotor shaft transfers the mechanical energy from the spinning blades to the generator inside the nacelle. The crane lifts the assembled blades and hub. This is a delicate operation, as the components are large and heavy. The crane operator must be highly skilled to maneuver the blades into position without causing damage. They are carefully attached to the nacelle. The nacelle houses all the critical components of the turbine, including the generator, gearbox, and control systems. Ensuring a secure attachment is vital for the turbine's operation. Finally, there are checks and tests. Electrical connections are made. Engineers and technicians conduct thorough inspections to ensure that all components are correctly installed and functioning as intended. The turbine is tested to ensure everything works properly. These tests include checking the electrical systems, mechanical components and control systems to ensure the turbine can operate safely and efficiently. Once everything is deemed safe and functional, the turbine is ready to generate clean energy. This marks the final step in the installation process, and the turbine can now contribute to sustainable power generation.